Welcome to the video. Today we are going to solve another Math Olympiad problem. So you can see that there are 12 points on a circle equally spaced, and we have to find the number of different triangles possible which are not obtained by rotation or symmetry. So let's get into it. So let's use a systematic method of plasma. So problem understanding, we know that we have to uh, get different triangles possible here, but we have to also avoid rotation and symmetry. So that is our clarity here so far. In terms of linking the concept, what we know is generally if you have to pick 3 points to form a triangle out of 12 points, you generally go after first is permutation, and 12p3. So you have to pick 3 points out of 12 in a permutation if all of these points are unique, but they are not unique, right? So it's not like this is labeled 12, this is labeled 1, this is labeled 11. And the orientation of these 3 points like 12, 11 and 1 is not a different triangle than 12, 1 and 11. Okay, so this will not work. The next that you will go is combination. So combination will be 12C3. So in combinations, at least 12, 11 and 1 will be one kind of a triangle, whether you count it as 12, 1, 3, 1, 12, 1, 11 or 12, 11, 1 or 1, 11, 12 or 1, 12, 11. These are all one triangle. So in combination, we capture that. Okay. Now, we are given that they are not obtained by rotation. Okay. So let's say 1, 2 and 3 is a triangle, and 2, 3 and 4 are also a triangle, is also another triangle. When these all points are fixed in a space that you cannot move them around, then this formula will work. But let's say if you have to rule out any rotation, then if you rotate these by 1, then 2, 3, 4 will become 1, 2, 3, which is the same kind of a triangle. And that will take out a lot many triangles out of the picture. So we do not have to count all those triangles which are just formed by rotation. Okay, so this won't work, this won't work completely. Then we have to also rule out any symmetry. By symmetry, I mean if you take this point 12, 1 and 9, so they form one triangle. But if I have another triangle 12, 11 and 3, they also form another triangle, but they are all symmetrical around this axis. So we have to also take out a lot of symmetrical triangles. So we have to avoid rotation, we have to avoid symmetry. So what essentially this means is we have to find the triangles which are unique in their side length, and you can move them around, you can flip them around, but you should always get a different kind of triangle. You should not get the same triangle. So their lengths, all 3 lengths together, cannot be the same. That is the key message here. That if you have let's say a 12, 1, 2, then you cannot have another 1, 2, 3 or by symmetry. So what I mean is you have to, let's say if there is a triangle 12 to 1 and 2, right? So we consider them as, we can consider that this is a length x, this is a length y, and from 2 to 12 we will take this whole length here. This is x, then this is y, and this is z. But z is corresponding to the whole arc. X corresponding to 12 to 1 arc, y corresponds to 1 to 2 arc. So this is an xyz pair, xyz set. So we have to find x, y, z set which is unique in a way that when you move them around, when you have x, y, z, y, x, z, z, x, y, they are all same. So once you have an x1 number, y1 number, z1 number, you cannot move them around. So all these individual set, it becomes a unique set, and even a different combination of them will also consider the same set. So we have to find different values of x, y, and z, or different arc lengths of x, y, and z. But we know that x plus y plus z is going to be 12. Right? X here, let's say in this triangle, x is 1, y is 1, z is 10. So x plus y plus z is 12 always. And we need to find a unique combination of x, y, z. So a triangle can be either equilateral or it can be isosceles or it can be non-equal sides triangle. Okay. So how many equilateral triangle is possible? When x is equal to y is equal to z, that means 4, 4, 4 is the only combination here. So there is only one 4, 4, 4 combination that can possibly come out. Right? 12, 8, 4, or you can say 1, 9, 5, or 3, they are all considered same. So everything is, there is only one set of triangle which will have 4, 4, 4 as side lengths, each side corresponding to the length of the arc. Then how many isosceles triangles are possible? Let's count that. So consider the first one will be 1, x and y are same. Then the z will be 10. The next is when x and y are 2, z will be 8. When x and y is 3, z will be 6. And then when x and y are 4, then we already have 4 here, so we do not want to double count. When x and y are 5, then we have 2 here. And when x and y are 6, so it will be 0. So there is no triangle possible with 6 arc length, right? So these are the 4 combinations, okay, for isosceles. Non-equal sides triangle. So when x is 1, y is 2, then z will become 9. So 1 to 9 is one combination. Then when x is 1, y is 3, then this becomes 8. This is another combination. When x is 1, y is 4, then this will become 7, another combination. When x is 1, y is 5, then 6 is another combination. When x is 1, y is 6, then this will become 5, 1, 7, 4, 1, 8, 3, 1, 9, 2, and 1, 10, 1 is already counted here. Okay. So 4 combinations here when x length is 1. So we are just trying to increase. So x is smaller than y is smaller than z. So we are going in that direction. Okay. Then when x is 2, We are 2, with 2 we already have 1, we already have 2. Now we have to go 3. So 2, 3, then this will become 7. When x is 2, this y is 4, then this becomes 6. When x is 2, this is 5, then this is 5, 5, 2 already here. So this is a repeat. We do not want to have that. Then when x 2, 3, 7, 2, 4, 6, 2, 5, 5 is already there, 2, 6, 4 is there, 2, 7, 3, then 2, 8, 2, 2, 9, 1. Okay, so all of them are here already. Then the next is when x is 3, so we have to go 3, 3 is already here, so we have to, and 3, 1 and 3, 2 are already here, so 3 we have to go 1 up 4. So 3, 4, and the thing is 5. Then 3 after 5 is already 4. Then 3, 6 is 3. 3, 7 is 2. 3, 8 is 1. And 3, 9 is not possible. Okay. So then 4. The next one, x becomes 4. So there will be only one combination here. 4, 4, 4. And 4, 5, 4, 5, 3 is already there. 4, 6, 2 is already there. 4, 7 is there. 4, 8 is not possible. And 5, I think all of them are common. So, okay. So this is the 7. So total we have, so total number of different triangles is 7 plus 1 plus 4 is equal to 12. And that's our answer. Hope you liked this video.